Hello and welcome, students. In last lecture of derivative, we have differentiated these functions with respect to x, and we got their derivative, which I have written under the column f dash x. So these are the different functions that we have differentiated. Now there are few more functions which I'm going to differentiate. Okay, so total we have differentiated 10 functions. There are few more functions I'm going to differentiate. What are those functions? I will write those functions under the heading f of x, and those all will be under the heading f of x, and their derivatives will come under the heading f dash x. So those functions that we are going to differentiate will be x squared, then it will be 1 upon x, then it will be root of x. These are three functions and one more function, that is constant. Okay, so let us start with, see, I will first begin with constant function. Let me begin with the constant function. Okay, and how are we going to differentiate constant function? Students, we will differentiate constant function using the first principle of derivative. Okay, so you must be thinking, sir, you wrote these three first, but then why are you differentiating constant function? There is a reason for that. I will explain you that reason later. Let me first differentiate constant function. So what is f of x? F of x is k. F of x is k, and f of x is a constant function. Okay. Now, what is a constant function all about? See, I write k, and here I write k is a constant. What is k? It is a constant. What is the meaning of a constant function? I will tell you that. See, a constant function is a function which will never change its value irrespective of what x value is. A constant function will never change its value irrespective of value of x. You may put x any number, the value of function will always remain k. That is why it is a constant function. If I put x is equal to 1, so put x as 1 here. So if I put x as 1, what I will get? I will get f of 1. And what is f of 1 equal to? Constant k. Okay. Then I will put x equals to 2. Where? Here. I will put x equals to 2. When I put x as 2, what I get? I get f of 2, f of 2, f of 2. What is it? It is again k. Why? Why is the value of the function not changing? The value of x when changed, why is the value of function not changing? Because there is no x on the right hand side. See, this function is independent of x. It is independent of x. It is independent of x. It is not changing. It is independent of x. There is no x here. So if you are changing x, there will be no change here. If you put x as 3, what will happen? F of 3, that will also remain k. Always k, k. Okay. So students, we have a function of x, which is a constant function. Okay. What will I do? What does Newton first principle of derivative says? It says that you increase x by a very small number. So I will next get f of x plus h. I will get f of x plus h. Okay. So students, as you know, the value of f of x plus h will also remain k. Now I write by first principle of derivative. I will write here by first principle of derivative. What I will get? I will get here f dash x is equal to, you all know, the change in the function value, f of x plus h, minus, see, this is final function value minus initial function value, f of x plus h minus f of x upon the change in the x value, that is h. And then you will go for limit h tends to 0. So what you will get? You will get your limit h tends to 0. F of x plus h is k. minus f of x is k upon h. What is k minus k? 0 upon h. What is 0 upon h? 0. So limit h tends to 0. 0 upon h is 0. Now tell me, when h is approaching 0, what number will 0 approach? 0 will remain 0. So you got 0. What is f dash x? 0. So my dear students, what we just got, derivative of k, the constant, derivative of k, the constant with respect to x, constant, derivative of constant with respect to x is what? It is 0. It is 0. Okay. Okay, students. So after this was our 11th function. This was our 11th function. Now I will go for 12th, 13th, and 14th. Okay, 12th, 13th, and 14th. See, till here it was 10 functions we had differentiated, 6 trigonometric function, 7, 8, 2 exponential function, log x, 9. This is 10, and then what? 11, 12, 13, and 14. Okay, so now I will go for x square. Now, how do I differentiate x square? See, if f of x is x square, I have to find f dash x. But you know, this time I will not use the first principle. Why? Because enough. We have done enough by first principle. Now I will do it directly. What do I mean by directly? See here, students. F of x is x square. What kind of function is this? I need to name it. Please understand, you need to name it. If you cannot name a function, you cannot answer. So what is the name? The name is variable raised to constant function. What is the name? The name is variable raised to constant. Very good. Do you have any function which is constant, variable raised to constant, and you already have differentiated? Yes. That function was f of x raised to n. Variable raised to constant, this function we have differentiated. What was its derivative? F dash x was n into x raised to n minus 1. Oh, so can I use this result here? Can I use this result here? See, when you say yes, we can use the result, remember students, it has to be exactly the same form. Okay, variable raised to constant, x raised to n. Please understand, x raised to n is variable raised to constant. And what is its derivative? Nx raised to n minus 1, which we have done. If I ask you, how is this the derivative? How? So you will say this is by first principle. This is by first principle. Okay. So let us apply it here. Let us apply. So what I will get? F dash x is equal to x raised to n, derivative is n into x raised to n minus 1. So 2 into x raised to 2 minus 1. That is 2 into x raised to 1. That is 2x. So remember students, is f of x is x square, f dash x is equal to 2x. This I hope you all have followed. What is f dash x? F dash x is 2x. F dash x is 2x. Students, now I have the 13th one, and see what was 13? 13 is 1 upon x. So I have f of x is equal to 1 upon x. You know what I will do next? I will write 1 upon x as f of x is equal to x raised to minus 1. It is x raised to minus 1. Once again, I am asking you, what kind of function is this? X raised to minus 1. See students, x raised to minus 1 is variable raised to constant. Variable raised to constant function. And what is variable here? Variable is x. See, when I have variable raised to constant, and variable, when I say variable raised to constant and variable is x, we have already differentiated this function by first principle. All the functions which are x raised to n, what is the derivative? N into x raised to n minus 1. So what will be the derivative of x raised to minus 1? It is minus 1 x raised to minus 1 minus 1. That is minus 1 into x raised to minus 2. Okay, now this x raised to minus 2 will go in the denominator. So it will become minus 1 upon x squared. What it will become? Minus. So this is f dash x. F of x is 1 upon x. So f dash x is minus 1 upon x squared. What is f dash x? F dash x is minus 1 upon x squared. Minus 1 upon x squared. So here I have 1 upon x. This is minus 1 upon x squared. Minus 1 upon x squared. When f of x is 1 upon x, its derivative with respect to x is minus 1 upon x squared. What did I do? Sir, this time you are not doing it by first principle. Sir, आप इसको first principle से क्यों नहीं कर रहे हो? इसलिए क्योंकि मैंने already 1 upon x जो है, that is x raised to minus 1, इस टाइप का फंक्शन मैंने by first principle पहले ही किया हुआ है. देखो x और पावर क्या है? n. जैसे यहाँ पे पावर n है, जैसे यहाँ पे पावर n है, वैसे यहाँ पे पावर क्या है? minus 1. What is the power? minus 1. Very good. Now, after this, students, we have the next one, and that is root of x, 14th. I'm now going for 14th, which is square root of x. So, square root of x. Square root of x. I write question number 14. F of x equals to square root of x. Okay. So I write this as, therefore, f of x, square root of x. Can I write x raised to 1 by 2? Definitely yes. So now I write, therefore, see, x raised to 1 by 2. X raised to 1 by 2. I ask myself, what kind of function is this? Can I name it? Yes. The name of the function is variable raised to constant. Variable raised to constant. Then I ask myself, that the part which is I'm referring to variable, is that variable x? Yes, that variable is x. See, there are lot of functions which are variable raised to constant, but that variable has to be x. Then only you can apply this result. See, for example, if I have log x raised to 1 by 2, log x raised to 1 by 2, what kind of function is this? This is also variable raised to constant. Please understand, this is also variable. Log x is a variable raised to constant, but you know, this variable which I'm referring to, it is not x. It is not x. So I cannot apply this result. This result which you have, derivative of x raised to n is n into x raised to n minus 1. This result is only when the variable is x. Because remember, when you applied the first principle, that time it was x. The definition that you got, the result that you have here, this result is only when you applied in the first principle, and there it was x. What it was? It was x. So you cannot apply for log x raised to half. No. Then you have a question. So for सर ये वाला रहेगा तो कैसे डिफरेंशिएट करने का? वो अभी बाद में आएगा. That will come later. Don't worry. So here we have f of x raised to half. So what will I write? I will write 1 upon 2. See, n x raised to n minus 1. So 1 upon 2 x raised to 1 upon 2 minus 1. That is 1 upon 2 x raised to 1 by 2 minus 1 is minus 1 by 2 x raised to 1 by 2 into x raised to minus 1 by 2. Half minus 1 is minus half. So this is 1 by 2 into 1 upon x raised to 1 by 2. 1 upon x raised to 1 by 2. That is 1 upon 2 into root x. 1 upon 2 into root x. So when f of x, this is f dash. When f of x is root x, what is f dash x? F dash x is 1 upon 2 root x. When f of x is root x, what is f dash x? It is 1 upon 2 root x. Yeah, hello students. You know the name of these 6 function is trigonometric function. Then you have these 2 function, exponential function. Then here you have a logarithmic function. The base is e, which is known as natural logarithm. Then here you have x raised to n, which is algebraic function, which is variable raised to constant. Algebraic function, which is variable raised to constant. Okay. Then you have another function here. This is a constant function. Constant function. Now, I'm taking you to these three functions. Okay. On the basis of how you differentiated, I repeat again, on the basis of how you differentiated, what you will say? You will say, sir, these all functions are variable raised to constant. See, they all are of the type x raised to n. How? See, this is x square, variable raised to constant. This is 1 upon x, that is nothing but x raised to minus 1. You wrote x raised to minus 1, then only you differentiated. So this is also variable raised to constant. Then you have root x, which is x raised to half. You again wrote this as variable raised to constant. So please understand, student, on the basis of how you differentiated, you call these three functions as variable raised to constant. So what you can say? You can say that for these three functions, what is the parent function? The parent. What is the parent function? X raised to n is the parent function. That is okay. But you know, students, when the children grow up, when the children themselves become independent, they have grown up. So they have their own world. They have their own recognition in the society. So same thing has happened with these three children of x raised to n. Who are they? They are all children of x raised to n. Now they have grown up. So we will give them their own name. Their own name. We will name them separately. So what is name of x square function? I will call this as square function. It is a square function. Please understand, student, when I say square function, I mean it is square of x. Okay. What is this? It's reciprocal function. Reciprocal function. Please keep writing the name of each function. Then what do I write here? This is square root function. Square root function. Square root function. Okay. So now please understand, students. We are at the basic level. We are at the basic level. We have differentiated 14 functions. We have named them all. In all the names, the variable is x. I repeat again. In all the names, the variable is x. The variable is x. It is very important. Listen to this. If you have a doubt, you must say that right now. See, what is this function? It is a trigonometric function, which is sine function. Trigonometric function, cos function, tan function, cot function, sec function, cosec function. Not a single time I said x. Not once. Not once I said x. It is understood. Sine function, sine of x, cos of x, tan of x. You understand? Yes. It is understood. But remember, having said that, you can even have sine of log x. Please. You can still have sine of log x. What is the difference? See, this is sine of x and this is sine of log x. What's the difference? There is a difference. The difference is when I say sine of x, the basic variable is x. But here, see, I say sine of x. So this is by definition the standard function, sine function, and it is the standard function, sine of x. When you are saying derivative of sine x as cos x, it is always for the standard function. Sine of x. What is derivative of sine of x with respect to x? Cos of x. Some students, some students will think as derivative, listen to this very carefully. Some students will think as derivative of sine x is cos x, derivative of sine of log x will be cos of log x. they will think it this way, which is not correct. Not correct. Why not correct? Simple. Why not correct? Not correct because this definition which you are applying, it is only applicable when you have the variable as x. So please understand that the list that you have here, my dear students, the list that you have here, by list what I mean this list that you have, this list that you have here, this list is only when you have the variable as x, no other than x, nothing other than x. The variable is x. So sine of x, cos of x, tan of x, cot of x, sec of x, these all definitions. What is derivative of sec of x? Derivative of sec of x is sec x into tan x. Now somebody will ask you, what is derivative of sec of x square? Please do not apply this. Do not write, do not think sec of x is sec x tan x. So sec of x square is sec of x square into tan of x square. No, it is not that. There is something more to it, which is going to come, which will come. Don't worry. But as of now, it is not the case. I hope you are following this. So students, in all these functions, please understand what is the name of these functions? Trigonometric function. Then constant raised to variable. Okay, not a single, yeah, very important. Not once did I mention the word variable. I simply said what? Sine function, cos function, tan function. But it is understood. If I am saying sine function, every function has some variable. So sine of x. Okay, now look at this, a raised to x. What is the name? Constant raised to variable. Yes, but here I am saying, I'm uttering the word variable. Okay, I'm saying constant raised to variable. It's okay. Here I'm saying constant raised to variable. For these two, I'm saying constant raised to variable. I'm uttering variable. Here I'm not saying sine of variable, cos of variable. So what? Though I'm not saying, variables are always there. Okay, you just cannot have only sine. It has no meaning. Just think, does it have any meaning? Just sine. You write nothing. That is impossible. Sine of x. मैं बोल नहीं रहा हूं x, लेकिन वो तो है यहां पे constant raised to variable. मैं बोल रहा हूं variable. ये देखो यहाँ पे व्हाट इज द फंक्शन? लॉग फंक्शन. दिस इज लॉग फंक्शन. मैं बोल रहा हूं वेरिएबल नहीं बोल रहा हूं, मैं सिर्फ लॉग बोल रहा हूं, लेकिन फिर भी एक्स तो रहेगा ना, एक्स तो रहेगा. वेरिएबल रेज टू कांस्टेंट यहां पे मैं बोल रहा हूं वेरिएबल रेज टू. तो मतलब आप वेरिएबल बोलो या मत बोलो, फंक्शन है तो वेरिएबल रहेगा ही. फंक्शन है तो वेरिएबल रहेगा. दिस इज स्क्वायर फंक्शन. दिस इज स्क्वायर फंक्शन. स्क्वायर किसका स्क्वायर? Obviously, x ka square, variable square. This is reciprocal function. Whose reciprocal? Obviously, x ka reciprocal. This is square root function. Whose square root? X ka square root, variable ka square. Okay. So students, you have to name everything. You have to know the name with all these functions. Students, if you remember in the very first lecture, I had said that along with Newton, there was one more contemporary of Newton, one more mathematician who was also working on the same concepts, and his name was Leibniz. Okay. Now we are going to learn, see, f of x, please understand students, f of x, and then it's a derivative, differentiate with respect to x. F of x, when you differentiate with respect to x, what do you get? You get f dash x. This is derivative of f of x with respect to x. What is f dash x? Derivative of f of x with respect to x. So what are these two, students? They are notations as per the Newton. These are the notations. They are the notations. You all know the meaning of notation. Yes, the symbols that you use. What are they? They are the notations as per Newton. Okay, fine. Now we are going to have the Leibniz notation. What we are going to have? Leibniz notation. This is the next step that we have. Leibniz notation. See, what does Leibniz say? He said that if f of x is termed as y, if f of x, the function of x is termed as y, then differentiating this with respect to x, see, you can always use the short form DIFF dot, that is differentiating WRT with respect to x. If you take f of x as y, just take f of x as y, then differentiating this with respect to x, it means you will write both the sides d by dx. What you will do? You will write d by dx. That is this particular statement, which is in English, differentiating with respect to x, you can write in notation as d by dx. What does d by dx stand for? It stands for differentiating with respect to x. That is what is d by dx. So Leibniz said that if y equals to f of x, then d by dx of y, you write d by dx on left hand side equal to, you write d by dx on right hand side, that is f of x, d by dx. Okay. So now what you will do? Okay, what is meaning of d by dx? What is meaning of d by dx? D by dx means differentiating with respect to x. It is differentiating with respect to x. D by dx means differentiating with respect to x. So tell me, students, what is derivative of f of x with respect to x? What is derivative of f of x with respect to x? So according to Leibniz, if we are taking f of x as y and we are differentiating with respect to x, if we are taking f of x as y, we are differentiating with respect to x, what are we going to do? We are going to write d by dx of y. We are going to write d by dx of y. And what is meaning of d by dx? That is differentiating with respect to x. So we wrote d by dx on the left and we wrote d by dx on the right. Okay. And then this d by dx which I have of f of x, it is nothing but the first principle. It is nothing but by first principle, whatever you had done. So what you will do? D by dx of f of x, that is derivative of f of x with respect to x. What it is? It is f dash x. So dy by dx is same as f dash x. So as per the notation, if you see what has Leibniz done, Leibniz only introduced y. If you simply remove y, Leibniz introduced y and d by dx. That is what Leibniz do. If you remove y and d by dx, you are getting everything what Newton had done. This is what Newton had done. Differentiating f of x with respect to x. What you got? F dash x, f of x and f dash x. But what did Leibniz do? Leibniz introduced d by dx and y. Okay. What did he do? F of x, he took it as y. And then he is writing d by dx on both sides. Why write d by dx? Differentiating with respect to x. So when you write d by dx of y, you will write d by dx of f of x. Yes. And what is d by dx of f of x? F dash x. What it is? It is f dash x. Students, see, what you have to do here is, see, I will write, let us take the first one. I will write y equals to, if y equals to sine x, see here, under y, you have sine x. F of x is y, and under y, you have sine x. So if y equals to sine x, then what is f dash x? F dash x is cos x, which is nothing but dy by dx. So I can write if y equals to sine x, dy by dx is equal to cos x. If y is equal to sine x, dy by dx is cos x. Okay. So if y is equal to sine x, then d by dx of y is equal to cos of x. Now, see, students, if I take this as 1 and this as 2, so can I substitute for y? What does 1 say? What does 1 say? 1 says y is equal to sine x. Y equals to sine x. So what I will do, I will, for this y, I will write sine x because y is nothing but sine. So in the next step, I will get therefore, d by dx of sine x is equal to cos of x. I will write d by dx of sine x is equal to cos of x. I got it. See this? What I got? I got d by dx of sine x is cos. Second. See, if y is equal to cos x, if y is equal to cos x, then d by dx of y, what it is? Minus sine x. Correct? If y is equal to cos x, then d by dx of y is minus sine x. Now what I will do? See, this one says y is equal to cos x, so I can put here cos x. Yes. So therefore, I will get what I will get. Therefore, d by dx of cos of x is equal to minus sine of x. So see, d by dx of sine x is cos x, d by dx of cos x is minus sine. Then you will write, see, the third one. The third is what? If y equals to tan x, if y is equal to tan of x, then d by dx of y, what it is? Sec square x. See, if y is tan x, what is d by dx? Sec square x. Correct? Yes. So this is one. One says y is tan x. I will put here tan x. So what it will become? Therefore, d by dx of tan x is equal to sec square x. Okay. So students, now see, as I got d by dx of sine of x, as I got d by dx of sine of x, d by dx of cos of x is minus sine x, d by dx of tan x is sec square x. I did 3 for you. You have to do the same thing for all 14 functions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. You have to do the same for all 14 functions. Okay? Thank you. See you in the next class.